In this video, you'll learn about memory contention, and you'll learn what the ESXi host will do to try to resolve situations in which it's running low on memory. And we're going to go through a number of memory reclamation techniques that the ESXi host will carry out. Now, that being said, let's kind of step back a little bit here and look at how the ESXi host actually provides memory to our virtual machines. So here we see two virtual machines. That's what the blue boxes represent. And our two virtual machines are launching applications. So as applications are launched within the guest operating system of the virtual machine, the guest operating system is tracking the memory that has been allocated to it. This is called guest physical memory. Now, it's not really physical memory. It's virtual memory. But that's not what the guest operating system thinks. Remember, our guest operating system doesn't know that it's a virtual machine. So as these applications launch within the guest operating system, the guest operating system is using its own memory table and allocating pages of memory to that application. And those pages of memory are then mapped back to actual physical memory pages on the ESXi host. And as more applications launch on more virtual machines, the process repeats itself. So anytime an application is launched within a VM or a VM is using memory for any purpose whatsoever, those memory pages are mapped back to physical pages of memory on the ESXi host itself. And this is great because memory is thin provisioned. A VM may be configured with 2 gigs of memory, but it won't actually use 2 gigs of memory unless it needs it, unless there's enough applications or memory demand going on inside that virtual machine to cause it to use its full allocation of memory. So that's one of the ways that our ESXi host is memory efficient. Now, as the ESXi host starts to run out of memory, it'll go through a series of memory reclamation techniques. These things only occur if the host is running out of memory. That's the only time this stuff happens. And the first memory reclamation technique is called transparent page sharing. Now, if you've been working with vSphere for a while, you might be thinking, I thought transparent page sharing happened all the time. It doesn't anymore. It used to. Now it doesn't. So the way that transparent page sharing now works is this. When the ESXi host starts to run out of memory, what it'll do is it'll begin identifying memory pages that are identical. Like, for example, let's say I've got 2 SQL virtual machines running on the same host, or I've got multiple processes running on the same VM, and we've got some pages of memory that are identical. Well, what transparent page sharing can do is it can deduplicate those memory pages to reduce the amount of actual host physical memory consumed. That's what transparent page sharing is. It's essentially deduplication for memory. And this used to just happen all the time in your ESXi hosts, but not really anymore. And there's a few reasons for that. But one of the main reasons is the fact that most guest operating systems now support large memory pages, and transparent page sharing cannot deduplicate large memory pages. So what it'll do is, prior to reaching a certain threshold, your host will start breaking up those large memory pages into small memory pages that can be deduplicated using transparent page sharing. So this is one of the ways that our ESXi host can help relieve memory pressure. Now, if the shortage of memory continues to persist and continues to get worse, the ESXi host will now start more invasive methods of reclaiming memory, one of which is ballooning. So here we see we've got contention. That's what that red arrow represents. We've got contention occurring on the ESXi host. There's not enough memory to go around, and now we need to start getting some memory back. Well, one of the funny things that happens when you launch an application in a virtual machine, or when the virtual machine takes up memory, we have to bear in mind that the guest operating system doesn't know that it's running within a virtual machine. So let's say some application launches in the guest operating system and then subsequently is closed. Well, that's going to free up memory in the guest operating system, but not at the ESXi host level. Notice those memory pages are still being consumed on the host physical memory. And this is a problem for my host because every time a VM stops using memory, the host never gets it back. So even if a virtual machine only uses memory for a very short period, that memory continues to be consumed on the ESXi host, till eventually the host starts to run out of memory. And when that happens, that's when ballooning kicks in. Ballooning is normal. Ballooning is not necessarily a bad thing. If you see ballooning activity occurring on an ESXi host, what that should mean to you is my host is getting back some of the memory that's not being used anymore. And hopefully, we should see that ballooning start up and then go away. That's what we want to see. Occasional ballooning activity is not a bad thing. Persistent, continuous ballooning activity, that is a bad thing. So here's what happens when ballooning occurs. The ESXi host, or what I'm calling the VM kernel here, the main process of the ESXi host, is going to utilize VMware tools to reach out into the virtual machine, into the guest operating system, determine those memory pages that are no longer required, and what it'll do is it'll actually pin those memory pages inside the guest OS so that they cannot be used by the guest operating system. And in that manner, it can reclaim those pages and free up that host physical memory. And then once the pressure starts to be relieved, the ballooning activity ceases. This is what we want to see. Occasional ballooning activity that kind of comes and goes. It frees up the memory it needs to free up, and then everything goes back to normal. And in most cases, this won't have any impact on the performance of the virtual machines at all. Now, what happens if we have transparent page sharing occurring and ballooning occurring, and the amount of free memory on the host is still extremely low? As a matter of fact, it's getting worse. Well, now the ESXi host is going to have to take more drastic measures. And one of the things that the host will do, if ballooning and transparent page sharing aren't enough, it'll start compressing memory pages. This is the last resort of the ESXi host before it starts swapping. So memory compression is bad, swapping is worse. What memory compression will do is it'll look for pages that are about to get swapped, and it'll try to compress them down to half their original size. And if it can do it, then it'll actually compress those memory pages rather than swapping them out. And that seems like a good thing. It seems like a win because we're not swapping. But the reality is anytime you compress anything, it takes resources to compress it, and it takes time to uncompress it. So if you're experiencing memory compression, you are experiencing diminished performance on your virtual machines. But it's still not as bad as the final option that your ESXi host has, which is host level swapping. Now with host level swapping, you've got a vSwap file for each and every virtual machine. Every VM, when you create it, has a vSwap file. Now in this case, we see VM1 has a 2 gig vSwap file. The reason that file is the size that it is because this virtual machine is equipped with 4 gigs of memory and a 2 gig reservation. And that's critical here. So the purpose of this vSwap file is just in case the host itself starts running out of memory and VM1 is asking for 4 gigs of memory, well, maybe the host can't actually provide a full 4 gigs of physical memory. So it might need to store those memory pages somewhere else. That's what the vSwap file is for. So for VM1, we know, hey, it's got a 2 gig reservation. It's always going to get a bare minimum of 2 gigs of physical memory. It's also got a 2 gig vSwap file for all of the rest of its memory, just in case there's not enough host physical memory to go around. And here we see another example. VM2 has 2 gigs of memory. It has no reservation. Therefore, it also gets a 2 gig vSwap file. And if things get bad, the host can carry out operations on that virtual machine. VM2 can continue to run, and we can put up to 2 gigs of memory pages inside that vSwap file. Now, the vSwap file is going to be way, way slower than the host physical memory. So again, this is a bad situation. Anytime you observe host level swapping, you know you have a system that is under extreme memory pressure. And really the only way to resolve that problem is to, number one, maybe you move some virtual machines to a different host. Use vMotion to get some of the VMs off that host. Or number 2, you could power off some virtual machines. Or number 3 is get rid of some virtual machines or purchase more memory. There's not a whole lot of great solutions. If you're experiencing this host level swapping, it basically just means you've got too many VMs and not enough memory. So your only options are really to get rid of some VMs or to get more memory. So that's a quick look at the phases that an ESXi host goes through when it's running out of memory. And just to quickly review, phase 1, it'll do transparent page sharing, which is deduplication of memory. Phase 2, ballooning, where the ESXi host uses VMware tools to look inside your guest operating system and reclaim memory pages. Step 3, and this is where things start to harm performance, is compression, where it's going to take memory pages and compress them down to half their original size. And then the worst case scenario, the final step, is this host level swapping, where it starts taking memory pages and storing them on disk.